Welcome. If you are aiming to answer that all-important level 6 to 8 inequality questions in GCSE Math, then this is the one tutorial you must watch. In this video, I'll show you how to graph straight line inequalities and shade part of the regions. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. Before we are able to shade the inequality regions, it is so important to be able to sketch the straight line graphs. For example, this vertical line has the equation x equal to 3, as all the points on the line have the same x coordinate of 3. On the other hand, if the line is passing through 2 on the x-axis, the equation of the line will be x equals to 2, and if it's passing through 1, it would be x equal to 1. Therefore, the equation of the line passing through y-axis is x equal to 0, and so on. Any vertical line have the equation of the form x equals to a, where a is a fixed constant. The vertical line divides the graph into two regions. For example, x equals to 3 divides the graph in two parts. X is greater than 3 on the right hand side of the graph. Any points on this region is always has the x coordinate bigger than 3. X is less than 3 on the left side of the graph, and any point on this region has the x coordinate always smaller than 3. If you want to show the region that x is bigger than or equal to 3, then this refers to the area to the right of the graph, and solid line is used to show that points on the line are also included. Likewise, x less than equal to 3 refers to the area to the left side of the line, and it also includes the point on the line. If, however, you want to show the region x greater than 3, then we replace the solid line with the broken line to exclude the point at x equal to 3. Similarly, x less than 3 refers to the area to the left of the line, and points on the line itself are excluded. All horizontal lines have the equation of the form y equals to a, where a is some constant. For example, the equation of this line is y equals 2. Y coordinate of this point on the line is always 2, as x coordinate varies. When the horizontal line passes through 1 on the y-axis, the equation of the line is y equals 1. When it passes through the x-axis, the equation of the line is y equals to 0, and so on. The horizontal line also divides the graph into two regions. For example, y greater than or equal to 2 refers to the region on and above the line, and y less than equal to 2 refers to the region on and below the line. We can again use the broken line to show that the points on the lines are excluded. Sometimes straight line graphs are neither vertical nor horizontal. They are sloping like this. These lines generally have the form y equals to mx plus c, where m is the gradient of the line and m tells us the direction of the tilt as well as the steepness of the line. C is the y-intercept and xy are the general point on the line. Y equals 2x plus 1 is of the form y equals mx plus c. In this case, m corresponds to 2 and y-intercept is at plus 1. In order to draw this straight line, we can generate some coordinates by using some negative and positive x coordinates, and then plot them on the graph. However, we can always draw a very accurate straight line graph even with just two coordinates on the line. This usually works best when these two coordinates are reasonably far apart. It is also possible to deduce from the equation that the y-intercept is at plus 1. So one of the coordinates that the line passed through will be 0, 1. Therefore, we only need to calculate one other point to be able to draw the straight line graph. Remember that we can make the line as long as we want, so long as the line passes through these two coordinates. All the points on the line follows the rule that y equals 2x plus 1. y greater than 2x plus 1 refers to the region above the line. We again use the dotted line to exclude the points on the line itself. We can use any coordinates on this region to verify that y is actually bigger than 2x plus 1. For example, we can use the coordinate minus 2, 0 and substitute this into the equation. The value of 2x plus 1 then is minus 3. This is lower than the y coordinate 0. Hence the y value must be bigger than the value of 2x plus 1 on this side of the line. Likewise, y less than 2x plus 1 lies below the line, and this too could be verified using the coordinate, say, 0, 0. Solid line here again denotes that points on the line are included in the regions of inequalities. Have a look at this example. In order to find the regions satisfied by all these three inequalities, it is easier to shade the regions that we don't want rather than the one we want. First inequality is y is strictly greater than minus 4. So we start with the dotted horizontal line passing through minus 4 on the y-axis. Region below this line is unwanted region, and we could shade them out. For x less than 2, we need to draw vertical dotted line passing through 2 on the x-axis. X less than 2 refers to the region to the left side of the line, therefore we shade out the region to the right side of the line which we don't want. We now need to draw the y equals to 2x plus 1 graph. This graph has the y-intercept at 0, 1, so this can be one of the coordinates that the line passed through. We can find another coordinate by substituting, say, x equals to 2 into the equation. This gives another coordinate 2, 5. We are now ready to plot the graph. Use the dotted line to join the points and extend the line to fill the space in the graph. We want the region y less than 2x plus 1. This lies below the line, so we shade out the area above the graph. If you're in doubt, we can verify that we have the right region shaded by picking any one point above the graph or below the graph and substituting this into the inequality. For example, let's pick minus 2, 0. Substituting minus 2 into the inequality gives y equals to minus 3. This is less than the y coordinate 0. Therefore, this point lies on the region where value of y is greater than the value of 2x plus 1. Let's check another coordinate, 0, 0. Substituting this into the inequality gives y as 1. This is more than y coordinate 0. Therefore, y is less than the value of 2x plus 1 on this side of the line. Hence, the area that satisfies all the inequalities is the region that is left over and unshaded. Let's look at another example. In this case, we start by drawing the vertical graph x equals to 2 with a solid line, as the inequality is greater than or equal to 2. Region to the right of the line is greater than 2, so we shade out the region that is less than 2. This is what we don't need. In order to define the next inequality, we need to draw the graph of y equals to x. Use two coordinates to plot this graph. Since y is equal to x, when x is 0, y is also 0. And when x is 7, y is also 7. So the line will pass through these 2 points. Since y have to be greater or equal to x, the area below the graph is shaded out, as y is less than x in this part of the region. Next, we need to draw the graph of x plus y equals to 6. When x is 0, y equals 6, so the line will pass through 0, 6. Similarly, when y is 0, x is 6, so the line will also pass through 6, 0. Now we are able to connect these 2 points with solid line. All the points on this graph follows the rule x plus y equals 6. X plus y is greater than 6 on the right side of the line, so it is shaded out as we need the regions where x plus y is less than 6. What is now left is a triangle where all these 3 inequalities are satisfied. Since we are only interested on integer coordinates, to answer part B of the question, we only need to show the coordinates that have the whole numbers. These points are 2, 2, 2, 3, 2, 4, and 3, 3. In this example, we have to satisfy 4 inequalities, and all of them should be drawn using dotted lines because inequalities are either greater than or less than. First graph can be drawn by using the points 0, 4 and 3, 0. Area we are interested is below the line, therefore we shade out the region above the line. Next we draw the graph of y equals 3x. This graph goes through 0, 0 and 2, 6. We need the region below the line, so we shade out the region above the line. We can now draw y equals 0 line and shade out the area below this line. And finally we can draw the graph of x equals 0 and shade the region to the left of this line. This leaves us with a triangular area where all the inequalities are satisfied. Since we are interested in integer answers, the coordinates are within this triangle. The points on the line itself are excluded.